Alright, moving through optimization problems. This one here is what we're going to do is we're going to set it up and then graph it and maybe try to get an approximation to this thing. Okay. Um, anyway, we want to find the minimum distance from a point on the curve, and this is going to be our curve x squared to a point in the plane, and that point is going to be on the x-axis 2, 0. So let's actually look at a picture. Alright, we have a point here in the plane, and that point is 2, 0, and then we have our curve, which is x squared. So we want to find the point on the curve such that if we were to find the distance between, let's say, this point here and 2, the distance, okay, we're looking at the distance between the point on the curve and 2, 0 here, and that distance is a minimum. So as you can see here, okay, if we were to look at the distance between 1, 1 and 2, 0, we could see that that distance is less than, we'll look at an extreme case here, that distance is less than, for example, up here at, trying to round off some numbers here, 2, 4, right? So the distance between 2, 4 and 2, 0 is obviously greater than the distance between 1, 1 and 2, 0. And of course, if you were to look at the distance between 0, 0 and 2, 0, you know that that's going to be greater. So we know that that distance is going to be, it looks to me like it's somewhere right in this area. Okay. All right, well, let's set the problem up. All right. So we have the point in the plane, and that point is 2, 0, and then we have our curve, which we'll just say it's y is equal to x squared. But more generally, if we were looking at a point on this curve right here, it's going to be x, and then our y value is x squared, right? So in our ordered pair, this is our x and this is our y. Okay, but instead of writing y here, y is equal to x squared. So we're going to use the distance formula, and just real quick here on the distance formula, remember what the distance formula is. It's the distance is equal to the square root. It's the change in x's plus the change in y's, and the difference in x's and difference in y's. So for example, we'd have 2 minus x squared plus 0 minus x squared, and that whole thing is squared. So this is the guy that we want to actually graph and take a look at what the minimum is on the graph and just get an approximation. And I think that's what we're going to do. I don't know, I may work through some calculus here. We're going to try to simplify this down a little bit. We have 2 minus x quantity squared plus, we've got square square, so that's x to the 4th there. Yeah, let's just go ahead and graph this, and then let's look at the graph. I have left our original curve here on the screen. Well, now remember, we're just concerned with the x, and remember what the y here represents, this 1.358. It represents the actual distance, alright? But the 0.835 is the number that we're actually looking for, and therefore if we went straight down, we're looking at 0.8, what was it, 0.83 something? Okay, so that looks about right, right? The distance between our cursor here and the blue dot is a minimum, right? So there it is. At the bottom is the minimum, and you know, we're pretty much done, because all you have to do now is take that 0.835 if we want to find what the y value is, right? What the y value is, of course, let's see.